Hello, welcome to my channel. We will be doing chapter number 10 from today. It's permutation and combination. Okay, so let's start with question number one. Question number one, part A. Okay, it says how many even numbers less than 500 can be formed using the digits 1, 2, 3, 4, 5. So we have 5 digits 1, 2, 3, 4, and 5. Okay, and using those 5 digits, tell we want to find out that how many even numbers can be found from these ones. Okay, so this is not a big problem, so I will try to do it exhaustively in a way that without using any formula. Let's try to write down all the even numbers. Okay, let's start with the single digit even numbers. So single digit even numbers using these 5 numbers can be two numbers only, 2 and 4, right? Now if I write double digit numbers, then the smallest double digit number using these digits could be 12, right? Can you think of anything else? Okay, the next one could be 14. So I kept the smallest number same, and the second number I put the second even number, right? So we have only two even numbers here, 2 and 4. Okay, now I have to change this tens. I make it 2. Now I cannot write 2 here because I cannot repeat the numbers. So I will write 4. Okay. And then I will again have to switch 2 to 3, that's the next number. And for the right ones, I have only two options, 2 and 4, right? Then again I have to change 3 into 4. And now I have only one option of even number, which is 2 here, right? You see, whenever I have odd number as tens, I can have two options. But even number, I have only one option. Odd, I have two options. Even, only one. And the next would be 5, right? So again, I have two options, 5, 2 and 5, 4, right? So how many is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are total 10 numbers up till now. Oh, sorry, right? So 10 numbers. Okay, now let's move down to 3-digit numbers. So smallest 3-digit number here would be 1, 2, 4. Okay, using these digits, the smallest even number I can write is 1, 2, 4 without repeating. I cannot repeat any digit. Okay, the next would be 1. I had to switch 2 to 3, the next one. And the smallest here is 2 here. Again, 1, 3, and 4. Again, I have to switch this 3. So I will make 1, 4. And with 4, I can write 2 only, but cannot repeat 4, 4. Right? Okay, so next would be I will switch 4 into 5, and then 5, 2, and then 1, 5, 4. Okay. Now I cannot make bigger than 5, so I have to switch this 1 into 2. 2, 1, and the smallest number would be 4 here. Make sense or no? Okay, next would be, okay, now I cannot go beyond 4, so I have to switch this one. So 2, I cannot make 2, I have to make it 3. And then the last digit, I cannot make it 2, I have to make it 4. Okay, so next would be 2, and if I make 3 into 4, I cannot write next number because this is 2 and 4 both are repeated here, are coming once. Okay, so next I have to make it 5, right? And with 5, the smallest number would be 4 here because I cannot write 2 here. Okay, so 2. Now I cannot make more than 5, so I have to change it to 2. So I will make it 3. 3, 1, 2. This is the smallest even number I can write with 3 in 300s. Next would be 3, 1, 4. And now I get to switch this tens to make it 3, 2, and this has to be 4. Okay. I again have to switch this this tens again. I cannot make 3, I have to make 4. So when I make it 4, I have to make it 2 here. And then I cannot make it 4, so I have to switch this 3 and 5. And again 2 and 3, 5, 4. Okay. And next would be, so I cannot go beyond this number, so I have to make it, I have to switch this 3. Okay, what happened to my pen? Oh, I guess. Okay, so this will become 4. Okay, so 4, 1, 2, this is the smallest number. Next would be 4, and I cannot make into 2 because then I use both even numbers. So I have to make it 3, 4, 3, and then I will make 2. Okay, next would be I cannot make 4, 4, so I have to make 4, 5. 4, 5, 2, and then last, this will be the last one because I cannot go beyond this one. Okay, so how many are these numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay, so these are 18 numbers. So 18 plus 10 is 28. So 28 is my final answer. Okay, I can write 28 even numbers less than 500 using these digits 1, 2, 3, 4, 5, and without repeating. Okay, I hope this is clear. Let's start question B. Okay, so B, it has two parts. B1. Okay, so a committee of 8 people is to be chosen from 7 men and 5 women. So we have 7 men. So 1, 2, 3, 4, 5, 6, 7. So these are all men. 1, 2, 3, 4, 5, 6, and 7 men. And they have 5 women. So 1, 2, 3, 4, 5. These are all women. 1, 2, 3, 4, 5. Okay. I had to make a committee of 8 people, and at least 3 should be men and 3 should be women. Okay. So let's start. Remember the concept of combination. When I say, for example, 5 combination 3, or I can write it as 5 combination 3. What's the meaning of this? Okay, if I use calculator, then 5 combination 3, let me save some time and use the calculator. 5 combination 3 is 10, right? What's the meaning of this thing? So this is same as 10. It means that if I have 5 things, right? 1, 2, 3, 4, 5, and I had to choose 3 from them, then how many different ways I can choose 3? I can choose 3 items from these 5 items. So how many different ways I can choose? So that is 10 different ways. Okay, I hope it's clear to you. So that's why I'm not explaining it further. But I hope that you understand the concept of combination. Permutation we will talk sometime, some other time. Okay, now if I have to choose at least 3 men from here, then how many ways I can choose out of 7 men? So this is going to be 7 combination 3. Okay, so if I choose 3 men from here, then I had to choose 5 women from there because I had to make a committee of 8. So all of them, so there's only one way because there's only 5 women, so I had to take all of them. So mathematically, I would say, um, 5 chose 5. I had to choose 5 item from the 5 item. So 5 chose 5 is 1. Okay, so this is uh, these are the number of committees we can form with 3 men and 5 women. Okay, now I can make 4 men and 4 women. So how many ways I can select 4 men? This is 7 combination 4. And how many ways I can select 4 women from 5? So this is going to be 5 combination 4. And the next one is, okay, let me select not 4 but 5 men and 3 women. So 5 men selecting from 7 is 7 combination 5. And if I have to select 3 women from 5, so from 5 women, I have to select 3 women. Okay, and that's it, not more than this, because I can not reduce the number of women less than 3. I cannot reduce it from 3, right? So this is it. So if I calculate these numbers, so 7 combination 3, I have done this calculation already, is 35, and 5 combination 5 is 1. You know this big, this is common sense. Okay, 7 combination 4 is again 35, and 5 combination 4 is 5. And lastly, 7 combination 5 is 21. And 5 combination 3 is 10. So this is 35 times 1 is 35, plus 5 times 35 is 175. And this is 210. And this all comes out to be 420. So 420 different committees can be formed. Okay, now let's do the last question, B2. Okay, again, we have to make a committee of 8 people from 7 men and 5 women. But this time, the oldest man or the oldest woman, but not both, must be included in the committee. Okay, so let's assume that this was the oldest man. The seventh man was the oldest here. Okay, and the fifth woman is the oldest here. Okay. Now we have no restriction of making at least 3 men or 3 women, but we have the restriction that we have to include the oldest man or oldest woman, but not the both. Okay. Okay. So let's assume that first I want to include the oldest man first. So if I want to include oldest man, and I make 2 more men from here. So 3 men and 5 women. So I cannot do this because when I include 5 women, then the oldest woman will also be included. So I cannot do this, right? So I cannot make 3 men. I had to make 4 men, right? And when I want to make 4 men, then one is the oldest one, definitely. So I have to choose 3 men out of 6. So 6 combination 3 is the way I can select 3 men out of 6. And then seventh is already included, the oldest person. Okay. And now I need to include the 4 women out of 4, because I don't want to include the oldest woman. So this is 4 combination 4. And of course, this is going to be 1. Okay. I hope everybody is with me up till now. Okay. Next, let's say I want to include one more man. So before I had 4, now I have to count 5 men. Okay, so when I count 5 men, one is the oldest one. I will take 4 other. So from 6, I will choose 4. Okay, now I have to choose 3 women from here, because I have already chosen 5 men. So 3 women. Uh, so from 4 women, I had to choose 3 women. Okay. Next. Okay. Um, okay. Now let's say I want to choose uh, 6 men. So one is the oldest one, and now I have to choose 5 more men. So from 6, I have to choose 5, and sixth one, the oldest one. And now I have to choose 2 more women. So 2 women will be from 4. So this is the number of women I have to choose from 4 women. Okay. And lastly, if I choose all seven men, one is the oldest and all the other six. So this is seven, sorry, six, choose six. Basically, this is going to be one only, right? So I choose all the men and I have to choose one woman out of four. So this is four combination one. Okay, so these are the number of committees when oldest men is been has been included in everyone. Now I want to count the number of committees with the oldest woman included. Okay, so when the oldest woman is included, uh, I will choose, let's say, yeah. So this one is included. So I have to choose four out of four, right? So I'm taking all five women basically. So it is four combination four. This is the number of the number of ways I'm choosing women. So five women I have chosen. Now, how many men I have to choose? Three. Three out of six. So it is six combination three plus. Okay, now let me reduce the number of women from four to three. So one is the oldest woman and three other women. So this is four combination three. Okay, so I'm choosing three women from here and the oldest woman. So this is four women I have selected, and now I have to select four men. And four men out of six would be six combination four. Okay, next one would be, okay, I want to include, okay, before I counted four women. Now let me take only three women. So three women mean one is the oldest, and I have to choose two out of four. So out of four, out of choose two women. So these are three women, and now I have to choose five men. So from six, I will choose five. Okay. And lastly, let me select only one woman from here. Okay. So one woman is the oldest one and one woman from here. So now four choose one. So this is the way I can select women. And now I just select, I have taken two women, one the oldest and one the other one, or one of the other one. So I have to select six men, and six men has to be all of these six because I cannot select the oldest one. So this is six combination six. Okay, and that's it. Okay, let me try to count. Okay, now you see there's a similarity here. This first term, this one, and the first term here is same. The similar in the next term, 4364 is the same. 6542 is same. 66 and 41 is same. So I can do the following. 2 times 6 combination 3 and 4 combination 4 plus 6 combination 4 and 4 combination 3 plus 6 combination 5 and 4 combination 2 plus 6 combination 6 and 4 combination 1. So I had to calculate all this thing again. It is twice, counted twice. Okay, 2 times. Now, what is 6 combination 3? It is 20 and 4 combination 4 is 1. Okay, 6 combination 4 is 15 and 4 combination 3 is 4. 6 combination 5 is 6 and 4 combination 2 is 6 as well. 6 combination 6 is 1 and 4 combination 1 is 4. So this will become 2 times 20 plus 60 plus 36 plus 4. and this all comes out to be 240. Okay, I hope this was everything is clear here. If you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.